So in this video, I'm going to be doing some contrast training between hang high pulls and some rocking vertical jumps. And with that, it's probably a perfect time to talk about some neuromuscular signaling. So first, we're talking about when my muscle contracts, the entire process. This is going to be two parts. This is the first one. So everything starts with a depolarization signal, which is going to be an electrical event created by the movement of sodium and potassium ions across a neuron's membrane. At rest, the inside of a nerve cell is negatively charged compared to the outside. This happens because the cell keeps more potassium inside and more sodium outside. Thanks to the sodium-potassium pump continuously exchanging ions, pumping 3 sodium ions out for every 2 potassium ions it brings in. This creates a strong separation of charge known as the resting membrane potential, usually at around negative 70 millivolts. A depolarization event occurs whenever the neuron receives enough stimulation to reach threshold. Once threshold is hit, a voltage-gated sodium channel snap open. Sodium, which is positively charged, is highly concentrated outside the cell, rushes inwards. The rapid influx of a positive charge flips the inside of the neuron from negative to positive, and that's the depolarization. Immediately afterwards, sodium channels close and voltage-gated potassium channels open. Potassium is going to flow out of the cell, allowing the membrane to repolarize and return towards its resting level. This precise sequence, sodium rushing in, potassium rushing out, creates action potential, the electrical spike that travels down the length of a neuron. The action potential is how your nervous system sends signals at an extremely high speed. Without the sodium-potassium pump maintaining that gradient, or without the controlled opening and closing of ion channels, your nerves wouldn't fire and your muscles would never contract. Every rep you lift starts with the tiny but powerful electrical event.